All right, let's talk about the N-ray affair, science's grand illusion. It's a wild story about a scientific discovery that completely captivated the world, a new kind of radiation with some incredible properties. But it's also a tale of ambition, belief, and, well, one of the greatest illusions in the history of science.
You really have to picture the scene. It's the early 1900s. The scientific community is just buzzing. X-rays and radioactivity were brand new, and the air was totally electric, with this feeling that we were on the verge of uncovering all of nature's secrets. So when a really respected French physicist announced he'd found a new N-ray, you better believe the world took notice. There was just one tiny problem. This new form of radiation, the one that kicked off this absolute frenzy of research, well, it simply didn't exist. It was all in their heads. And that's the real mystery here, isn't it? This wasn't just one person making a mistake. This was a kind of mass delusion that swept through laboratories all across France and even beyond. So how did that happen? I mean, the scale of this is just staggering. Over 300 scientific papers were published on the properties of these non-existent rays. So how? To understand what went wrong, we have to go back to the very beginning. So let's meet the man at the center of this whole storm and talk about the moment he believed he had changed the world of physics forever.
Again, you have to remember the context. This was probably one of the most exciting times in the history of science. It felt like physicists were peeling back the layers of reality itself. So finding another new type of ray, it didn't just seem possible. It felt almost inevitable.
And this part is absolutely crucial. René Blondlot was not some crackpot working out of his garage. He was a very accomplished, very respected physicist, a full-blown member of the scientific establishment. His reputation alone gave his claims immediate weight. And this wasn't just some abstract idea he was talking about. His work was based on actual experiments, using complicated-looking equipment like this, with wires, lenses, and radiation sources. It all looked perfectly legitimate. But here it is. Here's the fatal flaw in the whole thing. The entire method for detecting N-rays relied on a completely subjective judgment call. An observer had to stare at a tiny, faint spark in a pitch-black room and decide if it got just a little bit brighter. That's it. That was the evidence. Now you'd think an idea with such a shaky foundation would just fizzle out. But no, it didn't just take root. It absolutely exploded into a full-blown scientific craze. All of a sudden, researchers across France started discovering all sorts of amazing properties. They found N-rays could pass right through wood and metal, but were somehow blocked by water. And then things just got, well, really strange. A colleague of Blondlot's claimed N-rays were emitted by human nerves and muscles, and even, get this, from dead bodies. You can see the frenzy perfectly in the publication record. In the first half of 1903, there were just 4 papers on N-rays. 1 year later, that number skyrocketed to 54. That's way more papers than were published on actual X-rays in the same journal. But then look at 1905. Poof, the entire field just vanished. But before that collapse, the establishment was fully on board. Blondlot received a huge award, the Prix Leconte, and a hefty cash prize from the French Academy of Sciences. N-rays were officially a legitimate, celebrated discovery. So while everyone in France was celebrating, scientists in other countries were just scratching their heads. They couldn't make the experiments work. And all that skepticism led to the story's big climax, a fateful visit to Blondlot's laboratory. This really sets up a classic showdown. In one corner, you've got Blondlot, the believer, who is absolutely certain he's right. And in the other corner, you have R.W. Wood, a brilliant American physicist who just could not get the same results and decided he needed to see the evidence for himself. So just imagine the scene. Wood travels all the way to Nancy, France, and is welcomed into Blondlot's lab, the epicenter of N-ray research. The lights are dimmed for the delicate observations to begin. You could say the reputation of French science was on the line. In the first demonstration, the claim was that putting a hand in the path of the N-rays would make the spark dimmer. So Wood, in the dark, secretly moved his hand in and out of the path and asked the observer to call out the changes. As he later wrote, the answers were completely random. They bore no relation at all to where his hand was. But that was just the appetizer. Wood's real masterstroke came next. The next experiment used a special aluminum prism that was absolutely essential to disperse the N-rays. So in the darkness of the lab, Wood simply reached out and secretly pocketed the prism. Without that prism, the experiment was physically meaningless. It was like trying to take a picture without a camera lens. And yet, Blondlot's assistant kept right on calling out the measurements, as if nothing had happened. They were seeing effects that were now completely impossible. Wood had proven it. It was all in their heads. Wood published his account of the visit in the journal Nature, and N-ray research basically ended overnight. But it left behind this much deeper question. How could so many brilliant people see something that just wasn't there? Well, this brings us to a fascinating psychological principle. The phenomenon is called theory-ladenness of observation. I know it's a bit of a mouthful, but it's a simple idea. What you expect to see can literally change what you actually see. See, our perception isn't like a video camera just recording the world. It's an active process. We have bottom-up information coming from our senses, the raw data, but we also have top-down information, our beliefs and expectations, that constantly shapes how we interpret that raw data. Now, back in Blondlot's lab, that bottom-up sensory input was incredibly weak and ambiguous. It was just a faint, flickering spark. This created the perfect opening for that powerful top-down belief, I am a brilliant scientist on the verge of a great discovery, to completely take over and basically invent the perception of a change that wasn't actually there. The N-ray affair is so much more than just a quirky little anecdote from science history. It really offers some profound lessons about the nature of science itself. It's a powerful reminder that science is done by human beings, and we're all prone to bias and wishful thinking. That is precisely why objective, repeatable measurement is the absolute bedrock of good science. But, it also shows that science is ultimately self-correcting. A skeptic like Wood came along, tested the claims, and the illusion collapsed. The biggest lesson, though, is that the line between what we believe and what we see is way blurrier than we'd like to think. And so this whole story from over a century ago leaves us with a pretty provocative question. Before we judge those scientists from the past, we should probably ask ourselves, in our own fields, in our own beliefs, what illusions are our expectations creating for us right now? What N-rays might we be seeing today?